Hello everyone, welcome to SingTown Technology as OpenMV Robot ARM tutorials. Today we will teach you step by step how to set up the environment. Use OpenMV to control this robotic arm. Tutorials and source code are available on SingTown Technology website OpenMV.cc. Let's get started. Before we start working, let's quickly check the core components of this robotic arm. The display shows images captured by OpenMV in real time. It also shows the robotic arm's current coordinate information. Buttons control each axis as movement. You can customize each button as function as you like. The robot arm eyes is the device installed at the front, the OpenMV smart camera. It recognizes colors, shapes, QR codes, and barcodes. It tracks different objects easily. It runs AI neural network models for classification or detection. This makes the robot arm intelligent. This is the robot arm hand, also called the hand gripper. It is driven by a servo motor. Its opening angle is precisely controlled through programs. It is used to grab and release objects. Note that different projects need different end effectors sometimes. For example, in later tutorials, you'll see extended small grippers designed for playing chess. After checking the external structure, let's dive into the robot arm's interior. It mainly consists of two circuit boards. All functions rely on these two boards. First, let us look at this OpenMV Robot Arm expansion board. It connects directly to OpenMV. It extends OpenMV I/O pins. It facilitates connection to the arm. This is the serial communication port. It is the channel for OpenMV to send motion commands to the mainboard. This is the 5-volt drive interface. It outputs stable 5 voltage. It helps you connect and drive some small external devices easily, like the laser pointer in the demo. This is the FPC interface. It connects the LCD screen and buttons on the base. This is the ESP32 main board of the robotic arm. All movements are controlled by this board. These are stepper motor interfaces. They correspond to the 4-joint modules. The main board controls each joint as movement. This is the stepper motor driver chip. It is integrated on the main board. It provides enough current to drive the connected motors. These are limit switch interfaces. They judge positions during resetting. They tell the mainboard whether the arm has moved to the limit position. This prevents collision and damage. This is the 5-volt servo motor interface. It supplies power and control signals to your gripper servo motor. Finally, this is the relay peripheral port. It can be regarded as a program-controlled smart switch for external devices. It can switch higher voltage and larger current peripherals on and off, such as external air pumps or vacuum generators. High-power light strips. Simply put, OpenMV sends motion commands to ESP32 via the expansion board. The ESP32 mainboard controls the arm's movements. They cooperate with clear rows. Now that we know this, let's officially start our tutorial session. Step 1. Use the supporting 12-volt DC power supply or battery. Supply power to the robot arm. Step 2. Turn on the power switch of the robot arm body. Ensure the robot arm is powered on. Step 3. Connect the OpenMV smart camera to the computer via USB cable. Step 4. Copy the robot arm MPY module file to the root directory of OpenMV as built in storage disk. Step 5. Open OpenMV ID or OpenMV VS Code extension. Step 6. Import the robot arm control module. Step 7. Initialize the robot arm device. The arm uses serial port 3 for communication tasks. Step 8. Run the home setting function to reset the robot arm. The reset coordinates should be around the value 0, 174, 290. The coordinate origin is located at the center of the arm's base. Run this code to get the current XYZ and E coordinates of the arm. Use the set XYZ point function and input the target coordinates. The robot arm will move to the target position accurately. The 5 input values of the function represent X left right, Y front back, Z up down, E slide rail, and F movement speed. The value range of each axis is defined in the robot arm pi file. Use the servo angle function and input the angle value. 0 degrees means fully open. The maximum recommended angle is 76 degrees. This prevents damage to the gripper and servo motor from over-tightening. The gripper closes gradually as the angle value increases. You can control the relay module on the arm base via the relay function. It can drive external vacuum suckers, air pumps, and other similar devices. The Getty cable function reads the status of 3 limit switches in real time. It is used for safety judgment or process control operations. The OpenMV Robot Arm expansion board integrates a simple 5-volt driver. You can use it to drive devices powered by 5-volt voltage. For example, controlling a 5-volt laser pointer as on-off state via code. The RMS base integrates an LCD screen. and add buttons for operation. The LCD screen displays images captured by OpenMV at the current time. It also shows the robot arm's coordinates and other related information. You can modify the code to customize the display content freely. Currently, the LCD screen shows the robot arm current coordinate position. Next, we will modify the code part related to LCD display functions. As you can see, it now displays the current opening angle of the gripper. AD buttons controls the gripper as opening, 3-axis movement, and reset function. Of course, you can customize these AD buttons functions as needed. Let's take modifying button 5 function as a specific example here. Currently, button 5 is set to trigger the robot arm as reset function. We will change its function to increase the gripper as opening angle. After modification, press button 5 again. Its function changes from arm resetting to increasing the gripper angle. Now you have mastered all the basic operations of the OpenMV robot arm. Combined with OpenMV intelligent image recognition capabilities, you can create more amazing and cool projects. Source code and more content are available on SingTown technology, OpenMV.cc. Thank you all for watching this tutorial. Welcome to follow, like and leave your valuable comments. Bye!